class 10. So I am going to come with my new channel named C class 10 CBSE N class 10 CBSE IAN, that is the class 10 CBSE N. I have one channel. This is also a running channel. This is the name of the channel is the Mogojastro, where you can find the solution of class 11, 12 and engineering basically. And this channel is dedicatedly designed for class 10 upcoming class 10 CBSE board exam. So for this I am assured you that you just spent 40 to 45 hours on my upcoming videos and you get 100% common for your upcoming board exam. It is my assurance, and you just stick to my videos. That is, the chapters are discussed over these videos are very brief, and the methods, if possible, be tricky, and I choose every possible types of question from every chapters. You just stick to my video 30 minutes daily and keep practicing all the maths. I assured you again that you get 100% common. So let's start with the first chapter, that is called the real number. Okay, so in the real number there are five or six or maximum seven types of question, and the weightage of the real number is, just I am putting the name real number. Real number, and the weightage of the this chapter is 6. That means you have to score 6 out of 6 from this chapter if you stick to this video for 30 minutes. I am again assuring you, you will get 6 out of 6 if you go through this video. So if we consider this chapter, we get some types of math that you have to solve, and the um, types are discussed one by one. But before that, we have know some fundamental things that you have already learned in your class 9, and uh, uh, that types of question is not directly come, but the concept of that question might use in this chapter to solve some types of question. First of all, that is, one thing you have to keep in your mind, that the um, Euclid lemma or Euclid division algorithm or Euclid theorems are deleted portion, so don't go through that Euclid part. So first start with the fundamental arithmetic theorems that we have to learn about. Okay, so for that, first we have to go through some definition, and just only two definition. One is the prime number. I know that you have all know what is prime number. The prime number is one that has exactly two factors. One is the one and another is the number itself. That means if you consider 2, if you consider 3, if you consider 5, you consider 7, and if you factorize that numbers, you get only the factors, that is it is 1 and 2, that is 2 is divisible by 1 and 2 only, 3 is divisible by 1 and 3 only, 5 is divisible by 1 and 5 only, 7 is divisible by 1 and 7 only, rather than 1 2 1 3 1 5 or 1 7 2 3 5 7 respectively, doesn't have any other factors, so they are the prime number. It is very important. And the second thing you have to learn, that is what is composite number. Composite number. What is the composite number? A composite number is that number which can factorize into the prime number. That is a composite number. If we factorize any composite number, then we are get some prime number. What is prime number? Prime number is that number which doesn't have the factors rather than 1 and the number itself. So that means if you factorize the let's start take one big number, that is the 14, not big number, it is 2 into 7. That means 2 is a prime number, 7 is a prime number, so 14 is a composite number. And if you take the big number, that is, you can say that 3825. If you factorize 3825, then you get, so first start 5, 8, 16, 18. So it is divisible by 3, 3 1 ja 3, 3 2 ja 6, 3 7 ja 21, 3 5 ja 15. Again, it is divisible by 7 9 again it is the sum of the number is 15, so it is divisible by 3. It is 3 4 ja 12, 3 2 ja 6, and 3 5 ja 15, 4 25. So it is again divisible by 4 to 6 plus 11. It is not divisible by 3, it is divisible by 5. So 5 5 8 ja 40, 5 5 ja 25, again it is 5 17 ja 85. So it means that if you factorize 3825, then we get 3 into 3 into 5 into 5 into 15. So we know that 3, 3, 5, 5 all are the prime numbers, and 17 also the factors 1 and 17 only. So 17 is also a prime number. So 3825 is a composite number. Okay. Now the another thing you have to learn, means you have already learned, but I am again repeating you, that is the HCF and LCM. What is HCF? Highest common factor, and LCM is the lowest common multiple. Okay, so how can we find the HCF and LCM? Briefly I am discussing you, taking one example, that is, it is of if 48 and 72 are the two numbers, 48 and 72 are the two numbers given, and for that we are going to find out their HCF and LCM. What should we do? So we should break 48 into the factorized form. It is you can take the 48 over here and take its factorize. 24 to the 48, 2 12 ja 24, 2 6 ja 12, and 2 3 ja 6. So it is 2 into 2 into 2 into 2 into 3. That means it is 2 to the power 4 into 3. This is called the exponential form. To the power means the exponential form. Now we are going to break the for 72 like the same way. So take 72, and again 72, step by step we are factorize 2, 36 is 72, 2 18 is 36, 2 9 is 18, 3 3 is 9. That means 2 into 2 into 2 into 3 into 3. That means 2 to the power 3 into 3. So this is also 3 square. So this is also exponential form of the 2 and the exponential form of the 3. Now how would we find out the HCF? So for HCF, one important thing to find out the HCF, what we have to do? Identify the common prime factors and find the smallest exponents of them and multiply them. That means to find out the HCF, we have to identify the common prime factor. So here 2 to the power 4 and 3, here 2 to the power 3 and 3 square are the common prime factor. So 2, 2, 3, 3 both are common. Now find the smallest exponents. Here the smallest exponent is 2 to the power 4, and between 2 to the power 4 and 2 to the power 2 to the power 3 is 2 to the power 3. So here get 1 is 2 to the power 3 is the smallest among 2 to the power 4 and 2 to the power 3. And between 3 and 3 square, the smallest is 3 to the power 1. 3 means 3 to the power 1. So we are finding out the smallest common prime factors. Now multiply them. That means 2 to the power 3 into 3 to the power 1. That is the 8 into 3. That is the 24 is your HCF. You got it? For finding the LCM, the same up to this, the process is same. Identify the common prime factor, that is the 2 and 3 both are the common prime factors. But here for LCM we are taking the greatest exponents of them and multiply them. That means here for HCF we are taking the smallest among the common prime factors. Here for LCM we are taking the largest or greatest among the common prime factors. So here between 2 to the power 4 and 2 to the power 3, 2 to the power 4 is the largest, and between 3 and 3 square, 3 square is the largest. So we are 2 to the power 4 means 16 into 3 is 9, that is the 16 9 is 144 is the lowest common multiple, means this is the lowest number. This is the lowest number. That number is divisible by 48 and 72 both. And HCF means this is the lowest number by which 48 and 72 both are divisible. So one is, this is the lowest, that is the highest common factor, not lowest, sorry, this is the highest common factor. This is the highest number by which the 48 and 72 both are divisible, and this is the lowest number which is divisible by both 48 and 72. You got my point? So one important thing over here is that the note is that if I can erase this thing. If I have two number A and B, and the HCF and LCM we know, means we find, then HCF into LCM, LCM into HCF, sorry, HCF into LCM is equal to the product of the numbers. That means here the HCF is 24 and LCM is 144. That is the HCF into LCM. If you multiply them, this is equal to the product of the number, that is the 48 into 72. This is one important thing you have to know to solve the next questions. Okay, so let's start about the types of the questions. So first type of the question is, if we are checking the new page, if the HCF of type 1 T1, that is the HCF of two number, are given LCM of that two number are also given, and third point is one of the number is given. That means that if that type 1 is, if HCF, it says that HCF is equal to 23 and LCM is equal to 1449, taking an example, and one of the number, that means the one number is 161, find the other number. That means if A and B are two number and the HCF of A and B is 23 and LCM of A and B is 1449, and between A and B one is 161, find the other. It means that I can consider that A is 161, find B. That means it is easy. We know that HCF into LCM is equal to product of the number A into B. So HCF is 23, LCM is 1449, is equal to A is 161 say, and B we don't know, we have to find B. So what is B? B is equal to 23 into 1449 by 161. That means we can make that simplest form, it is the 207. It means you can practice it, or you can prove it, that if A is equal to 161 and B is equal to 207, then the HCF of them should be 23 and LCM of them should be 1449. This is the type 1. For again, for that, if we are considering this theorem again, then the type 2 is, that is the type 2, that is if HCF of two number is given, find LCM of them. That means you can take that HCF of 81 and 54 is 27. Find LCM of 81 and 54. It is very easy. It means A is 81 and B is 54 and HCF is 27. So A into B is equal to HCF into LCM. Now what is A? It is 81 into B 54 is equal to HCF is 27 and LCM we don't know. So to find LCM, so LCM become 81 into 54, এটা নিচে চলে আসবে, this should be in denominator 27, so 27 3 ja 81, 54 into 81 is 162. So that means the HCF of 81 and 54 is 27, but LCM of 81 and 54 is 162. Very important. Now go to the next part, that is the next type 3. Important, very important. This is depend upon only one theorem, that is you are asked to find that, show that, the question should be like this, show that 12 to the power n or 9 to the power n, whatever it is, 12, 9, it may be any digit, it may be 15, it may be 20, it may be whatever it is, 12 to the power n or 9 to the power n or 24 to the power m, whatever it is, can never end with 0 for any for any for n is equal to any natural number. It means 12 to the power 0 or 9 to the power 0 or 12 to the power 1 or 9 to the power 1 or 12 to the power 2 or 9 to the power 2, like this, like 12 to the power 50, 9 to the power 1000, whatever it is, it may be n, this is n may be 0 to any number. If we solve this, that is 12 to the power 2 is 144, 9 to the power 3 is 9 into 9 into 9, 9 into 9 into 9, that means the 81 into 9, 9 ones are 9, 8 nines are 72, 729. So whatever the number is, 12 to the power 0, 9 to the power 0, anything, any exponents, 50, 100, 1000, 1 lakh, 1 crore, whatever it is, that never end with 0. That means end digit cannot be 0. End digit cannot be 0. How can we solve it? That there is only one note you have to remind, that is, note is what? Any exponents can end with 0 if the number must have 2 and 5 as a factor. What does it mean? That is 12 to the power n is given. Now we have to factorize the 12. So 12, if we factorize, it is 2 into 2 into 3. That means 2 square into 3. Is it in the form of 2 and 5? 2 is present, okay, it's okay. But is there any 5? There is no 5, here is 3. If it is 2 square into 5, then the number become 4 into 5, that is the 20. And if 20 is the number and if it has any exponents, then it obviously ends with 0. You can say that 20 to the power 1 is 20. So it is end with 0. As it is, if we factorize the number and we are not getting the number in the form of 2 into 5, that's why this number with its exponent, any natural number exponents cannot end with 0. Got it? Now again same thing will happen. 9 is 3 into 3, that is its factor is 1, 3 and 9. So we can write 9 as 1 into 9, that is the 1 into 3 square. So here it is also not in the form of 2 to the power something into 5 to the power something. So these two numbers with having its any exponents cannot end with 0. It is very important aspect. Okay, now the most important thing that you will get from uh, your upcoming exam, that is the irrational number. But before irrational number, but before that you have to know one thing, that is the composite number. So you know what is composite number. So you know what is composite number. I have already written that the if the number is factorized and we get the factors as a prime factor, then the number is composite. Like let's type 4. In the previous it is type 3, now it is type 4. Taking type 4, T4. So proof of composite number. That means what is the proof? That is the 17 plus 11 into 13 into 17 into 19. Is this number is composite? Or you can take another example, Small example, 5 into 7 into 11 plus 7. Is it composite number? So let's solve it. So here you can see that here plus is between these two number. So and the 17 is common. So taking 17 as common, it is 1 plus 11 into 13 into 19. So if you solve it, 17 into, it is 2718. Now if you factorize 2718, you can solve it by own. The 17 into 2718 become 2 into 3 into 3 into 51. So here you can see that these, now if we solve this, we are getting 17 into this means, that means this, then the given numbers in the form of into and plus or minus, and but here we are going to we are going to that number convert it into number in the form of the multiplication, 17 into 2 into 3 into 3 into 15, all these things. Okay, so here all we can write 17 into 2 into 3 square into 51. So these, all these numbers are nothing but the prime factors. That is the 17 is also a prime number, 2, 3, 5, all these numbers are prime factors. Here also if you take 7 as common, here 5 into 11 is left plus 1 is left. So 7 into 56, that means 7 into 7 into 8, that is 7 square into 8 means 2 cube. So 7 is also a prime number, 2 is also a prime number. So as we convert this number into the form of the factorized form, and the factors are prime factors, that's why this given number is a composite number. Okay, so this is up to part 1. So we will come with the part 2 in the next video.